Okay, here we are, lesson 6-4. And let me see if I can get this moved down. Standard form of a linear equation. So, first of all, we need some vocabulary. We're going to start with the y-intercept. Oops. Let's go down here. The y-intercept. Oh my goodness. There we are. The y-intercept is a place where the line crosses what? The y-axis. You know that from y equals mx plus b, where b is the y-intercept. And if you think about it, every line, when you draw lines where they cross the y-axis, I want to know what my x value is. So what does x always equal when the line crosses this y-axis? And hopefully you said 0. Well, if the y-intercept is where a line crosses the y-axis, what do you think an x-intercept would be? Hopefully you said the place where the line crosses the x-axis. And once again, if you have a line, what would y equal this time? What's your y value where the line crosses the x-axis? What are those y values? So hopefully you said 0. Okay. Now, what is the standard form of a linear equation? So the standard form, I'm just going to abbreviate this. The standard form of a linear equation is ax plus by equals c. It's very important you realize that a, b, and c have to be integers. Think, what does an integer mean? Positive and negative whole number. So no fractions or decimals when we write in standard form. And a and b cannot both be 0. They cannot both be 0. So let's go to next page. So let's find example 1. Find the x and y intercepts of negative 2x plus 5y equals 20. Well, let's find the x-intercept first. If you think about it, what did we say was the y value when the line crossed the x-axis? And that answer is 0. So this is just going to be negative 2x equals 20. So x equals, oh, Miss Mayberry. There you go, 20x equals negative 10. So negative 10, 0 would be a point on that line, and that would be the x-intercept. Now let's go with the y-intercept. Well, the y-intercept, I'll try to write it real small over here, is the y value when x equals 0. So you're just going to put 0 in for x. Gonna get that 20 in there. Woo! There we go. So this is just going to be 5y equals 20. So y equals 4. So the other point on your line is 0, 4, and that's called obviously, the y-intercept. Now, a quick way of doing this is realizing, kind of covering up, all right? If you're asked for the x and y-intercepts of this problem right here, for example 1, 3x minus 2y equals 6, if you think about it, if you're finding the x-intercept, well, if y equals 0, the negative 2y is gone. So the x-intercept is just going to be 3x equals 6, and x equals 2. So 2, 0 is the x-intercept. And if I can erase this, if you go back, the y-intercept is going to be the y value when x is 0. Make sure you lasso that sign. There's a negative in front of that 2y. So it would be negative 2y equals 6. So y would equal negative 3. So the y-intercept would be, oops, I goofed over. No, I'm good. The y-intercept would be 0, negative 3. So if you wanted to, you could plot these points, right? 2, 0, boom, and 0, negative 3. And you could graph that line. Let's see if it's going to let me do this. And just graph that line, right, through those 2 points. So let's graph 3x minus 2y equals 12. Once again, I'm going to find the x-intercept first by just knowing that when I put 0 in for y, negative 2 times 0, whatever, is 0. So the x-intercept is just going to be 3x equals 12. So x equals 4. So 4, 0 is the x-intercept. 1, 2, 3, 4. And let me erase this first. Oops, didn't get the eraser. The y-intercept is going to be where the x value equals 0. Oh my goodness, it's not letting me. So then this would be negative 2y equals 12. So y would equal negative 6. So 0, negative 6 would be the y-intercept. Go down to 0, 1, 2, 3, 4, 5. I'm going to have to go down here. Right? That would be my y-intercept. And if I went to graph, connect these points, that would be my line. So why don't you try this one? So take a break, turn the recording off, try to find the x and y intercepts on your own. All right, so back we are. And oh my goodness, get this erased. Undo line. Okay, so hopefully, real quick, I'm just going to give you the answers here. You realize that 3x equals 15. So x equals 5 is the x-intercept. 5y equals 15 is the, and then y equals 3 is the y-intercept. So 5, 0 and 0, 3 would be your two intercepts. Now, what I want you to think about is if I give you the equation 2x plus 5y, I want you to think of a limitation of finding the x and y intercepts to graph. Right? So find those intercepts and tell me what might be a limitation to finding the intercepts if all you want to do is graph the point. So turn the recording off. When you come back, I'll have the answer for you. So the answer would be x equals 3 would be your x-intercept, but your y-intercept is 6/5 or 1.2. Are you going to be able to find exactly 1.2 on your graph? So that might be a limitation you might consider. All right, the graph of y equals 4. So notice we have no slope. All we do is have the equation y equals 4. All that means is no matter what x equals, y will always equal 4. So what type of line is that? This is a horizontal line. Okay, the slope is 0. Because to get from one point to the other, I go up 0 over. So anytime you have y equal a constant, that's going to be a horizontal line. How about x equals -3? Well, x equals -1, 2, 3. That means x will always be -3. I don't care what y is, x is always going to be -3. Now, so there is your vertical line. So vertical lines will be x equal to a constant. So think about what your slope is. Right? To get from one point to another, I go up 1 and divide by 0. And what's the problem with dividing by 0? Think about that. Now we want to write examples in standard form. So remember, standard form is ax plus by equals c, where a, b, and c are integers, no fractions, and a and b can't be 0 at the same time, which makes sense. So we're going to take this. The first thing I'm going to do is subtract -2/3 x, because I want it in this form. So I want to get my x and my y all together, meaning on the left-hand side. So I'm going to subtract 2/3. So I'm going to make that -2/3 x plus y equals 6. Problem, that is not an integer. What can I do to make it an integer? I say, let's multiply both sides by 3. The multiplication property of equality, that's a legal move. I'm not changing the equality. Right? So when I distribute, I get -2x plus 3y equals 18. So notice you can go from slope-intercept form to standard form, but we can also go from standard form to slope-intercept form. So we did that one correct. Yes, all right. So how about this one? 1/2 y minus 12x equals, 1/2 y minus 12 equals 3/4 x. So I'm going to get my x to the left and my constant to the right. So this one up here, I'm going to make that -3/4 x, because I just subtracted 3/4 x from both sides, plus 1/2 y equals, I'm going to add 12 to both sides. Then I'm going to multiply both sides by 4, because that's my least common denominator. So you're going to have -3x, right, plus 2y equals 48. That's correct standard form because a, b, and c, my a is -3, my b is 2, and my c is 48, and they are all integers. And I don't have much time left, so let's do this one quickly. Write an equation in standard form to find the number of hours you'll need to work at each job to make $130. So I'm going to call mowing lawns x, and I'm going to call my daily newspapers y. So basically, 12x plus 5y equals 130. So write the equation in standard form, find the average hours you would need to work at each job to make $130. So we could just solve this. You could pick hours for x and figure out what y would equal. So let's say I'm going to pick x equals, I'm almost done, equals 2. So 12 times 2 plus 5y equals 30. So 5y is going to equal, this is going to equal what, 24, and I'm going to subtract it, so that's going to equal 6. Y is going to equal 1.2 hours. Okay? So you'll see in Chapter 7 that writing equations in standard form are going to be very helpful when we have to find where two lines intersect and it's not on a great integer. So answer your questions on that quiz for the